Hi Izzy, hi Ellie. So I'm going to go over your quizzes, quiz 18 through 20, and then on to your tests, chapter 8 or test 8 and test 9, so you can get caught up on these things. And I'll go over the questions. So, well, let's begin. I know chapter 11, 12, 13, and 14. So the last is over all of this, all of these few chapters that I've been going over. So quiz 18, go ahead, get your quiz out. The first says, which would you expect to be more soluble in a polar solvent, such as water? So they give you two choices. One is CH4 and the other is CH2O. And one is nonpolar, CH4 is nonpolar, and CH2O is highly polar. Okay, do you remember like dissolves in like? So that's what we have to do. So if it's a polar solvent, it would be more soluble in a polar solvent. So which one of those is polar? The highly polar one. So like dissolves in like. So the answer would be CH2O. That's carbon H2O. So CH2O is highly polar, and we have a polar, so it's good that polar dissolves polar and nonpolar dissolves nonpolar. Polar just means it has ions on both sides, two poles, two different poles on the sides of the molecules, a north pole and a south pole, but a positive and a negative. Okay? Number 2. Name 3 ways to increase rate at which a given substance dissolves in another. So how do you dissolve a substance in another? Well, one thing, stirring. Another thing, grinding it up into little bits, right? Another thing is to heat it up. Heat it up in the microwave or something. And these will dissolve. So stirring, grinding, and heating are the 3 things. That's pretty easy, common sense, huh? On to number 5. Henry's law describes the effect of what, a blank, you have a blank there, on the solubility of gas. So it says A, temperature, B, density, C, volume, and D, pressure. Henry's law, we studied that, is always has to do with pressure. So in fact, I think there's going to be a question on your test that says basically talks about pressure. Like if atmospheric pressure, if you had pressure on the top of a mountain, would be not very much atmospheric pressure, or at sea level. And that's why if you basically, take a soda and open a soda, on the top of the mountain, it's gonna frizz more than the soda at sea level. And why? Well, here's the answer. Because Henry's law has to do with the solubility of a gas, which is that gas that's inside of your soda, which is, carbon dioxide or so in your soda. And so that pressure causes it to frizz more, where it's not going to dissolve for really well yet, at your pressure. So the higher the pressure, the better it dissolves. Let's just say that. So that's Henry's law. So you can put that in your memory, Henry's law, when we get there, okay? So the next is number 6. An ion or molecule that is surrounded by water molecules may be described as A, miscible, B, solvented, C, hydrated, or D, absorbed. Well, it's by water, it's surrounded by water, so what's the word for water? Hydrated, right? When you're well hydrated, you're drinking a lot of water. So if it's surrounded, a molecule surrounded by water will be what? Hydrated. Number 7. Which of the following occurs when an ionic compound dissolves in a solution? So what is an ionic compound? It basically, ions are positive and negative. So, excuse me, they are divided into positive and negative. So we're going to see which of the following occurs. So let's look. when it dissociates and it gets ionic. So A, the substance changes form on a crystal structure to another. That kind of sounds kind of weird, huh? Number B, positive and negative ions become separate another from each other. That sounds pretty good. I already described that. So, and the other says the changes of positive and negative ions are neutralized. No. D, the attraction between ions increases. No. Basically, what happens when they dissociate is they come apart. So B would be your answer. Positive and negative ions become separated from another. Let's go on to number 8. When table salt, so what is table salt? Sodium chloride, and sodium is NaCl. Sodium has the symbol is Na. So when table salt is dissolved in water, the salt acts as the what? Okay, you have different parts when you dissolve something. You have the solution, and you have the solution. Another name for the solution would be the solvent, that you're dissolving things in, and the solute. So what would the salt be? The salt is dissolving in the water. So basically the salt would be the solute. S-O-L-U-T-E. Solute is the whatever is dissolving, right? It's always the smaller thing that's dissolving in the bigger thing. So number 9, the substance in the same phase that are completely soluble in each other, such as ethanol and water, are what? What do you call them when they completely dissolve in each other into a clear solution? You'd call them, there's a word there that you learned in this chapter, it's called miscible. M-I-S-C-I-B-L-E. M-I-S-C-I-B-L-E. Miscible. Miscible means they dissolve perfectly in each other. They don't settle out, but they dissolve. They're miscible with each other. So we're saying ethanol, alcohol, or whatever is miscible in water, means it dissolves well in water. So number 10, a solution that contains as much dissolved substance as possible at equilibrium at the given condition is a blank solution. So basically it's saying if a solution contains as much, it can't hold any more dissolved, substances. It's at equilibrium now, so it's already dissolved. It's not going to go any further. What do you call that solution? There's a word that we learned in this chapter, and the word is saturated. When something is saturated, it means it's full, and it's not wanting to hold any more. Now, there is an unstable state called supersaturated that you force more stuff into it, but it doesn't last long. But basically, when something's at equilibrium and it's already stirred up and sitting there and you can't put any more in, it's called, or without it reacting, you call it saturated. The word saturated, you know what that means. So S-A-T-U-R-A-T-E-D, saturated solution. So that was quiz 8. We're getting through these, aren't we? So let's go to quiz, that's quiz 18. I'm sorry, quiz 18. Let's go to quiz 19. So quiz 18, quiz 19. I hope I didn't say quiz 8. I kind of labeled it wrong, but it's quiz 18 that we just did, and now we'll go on to quiz 19. Quiz 19, the first question. Colligative properties depend primarily on the mass of the solution. Is that true or false? Colligative means colloids. It's filled with little particles of colloids. And so colligative properties depend primarily on the mass of the solution. The mass has nothing to do how much it weighs. So that's false. So what does it depend on? It depends on the concentration. Concentration means how many molecules are concentrated in it. More concentrated have more molecules, in it. So the more molecules in it, the more colligative properties there are. Means it's going to be like cloudy, So the more concentration. So it depends on the concentration of particles in there, meaning more particles. Okay, not on the mass, not how heavy it is, because hey, gas is not even heavy. So on to number 2. If a large concentration of salt were added to pure water in a covered beaker, the vapor pressure of the water would be expected to decrease. So let's look at that. So if you had a large concentration of water and you added a concentration of salt, and you added into pure water, the vapor pressure means when basically the vapor is evaporating, and turning from a liquid to a gas. Would this decrease, or it says true or false? It's decreasing. So basically it would decrease. If you put the more salt you put in it, the less or the vapor pressure, the pressure of the vapor is going to get less. Okay. I hope I described that one. It's kind of hard, but that would be true. Okay, number 3. As the temperature of a given liquid is increased, its vapor pressure decreases. False. As you take the temperature and the temperature goes up, what happens when you're boiling water and you get to that boiling part of vapor pressure and you raise your temperature? As the temperature gets hotter, more molecules are going to want to come out. So basically that the vapor pressure increases. So increases, and so that would be false. So number 4, the boiling point of a solution, just a second, I have to sneeze or something. Oh, excuse me. Sorry, I've been kind of getting over a cold. So number 4, the boiling point of a solution containing a non-volatile solute is higher than the boiling point of the pure solvent. So is this true or false? So if you have a boiling point, you always think, remember it says as the boiling point, as you put more solvent into or put more the solution, more stuff, non-volatile stuff in it, and make it thicker, the boiling point gets higher. You know that because basically, you're going to boil at a lower temperature, pour a bunch of more salt in, pretty soon it raises the boiling point to a higher temperature. Now a freezing point is just the opposite. As you put more salt and stuff into it, it lowers the freezing point. That's why they put salt on ice and stuff, because it basically lowers the freezing point. So freezing point going down is lower, boiling point goes up when you put more particles in, like salt. Okay, so that statement is true. So number 5, the freezing point of a solution containing a non-volatile solute, like salt, is higher than the freezing point of the freezing point of the pure solvent. So no, basically the freezing point goes lower. So that's false, and it would be not higher but lower. So number 4 is true and number 5 is false, goes lower. Number 6, when calculating a solute's effect on boiling and freezing points, concentration should be measured as molality. Yes, remember we went over that. And molality is basically has to go with weight of the moles, and we went over those problems in your chapter. So true. Number 7, which of the following statements best describes what is meant when a liquid and its vapor are said to be in equilibrium? So equilibrium means they're equal. The vapor and the liquid would be equal. So which one of these it says is true about it? A, the mass of vapor and the mass of liquid are equal. No, we don't really measure mass there. So B, the liquid and its vapor are in a closed container. C, increasing temperature will increase the amount of vapor. So increasing temperature will increase the amount of vapor. Number D, the rates of evaporation and condensation are equal. Yeah, that's vapor pressure, D. The rates of evaporation and condensation. That's what we're talking about with vapor pressure. So number 8, what is the concentration of a solution containing 2.4 moles of sodium chloride, NaCl, dissolved in 3 liters of water? So what are you going to do with that? You got some numbers here. So one thing is always going to be the moles divided by liters, right? So we have the moles, so it's 2.4 divided by 3. So it's 2.4 divided by 3 is what? So what's 24 divided by 3? 8, right? But 2.4, you'd move the decimal, and so it would be 0.8. So that one's pretty easy. So it would be 0.8 moles, which is A. It's just you take 2.4 divided by 3, and 24 divided by 3 is 8. Then you move the decimal point over. So that one's not hard. So number 9, a chemist wishes to prepare 1.0 liters of 0.10 moles. So when you have of there, you know you're going to multiply those two things together. And then H2SO4 by diluting the concentrated 18 milliliters of H2SO4. How much concentrated H2SO4 is required? So what are you going to do with this one? So basically, the first thing you know you're going to have to do is multiply. If you multiply 1 times 0.01, what are you going to get? Well, of course, it's like 0.01 because 1 times itself is going to be itself. And so in that point, you're going to know that. You know, basically putting this in, so you're going to times that, but now you're going to have to divide then by, so the solution containing 500 grams. So then you're going to have to divide by the, is it 18? Oh, so 18 divided. So you're going to take 0.100 divided by 18 because it says 18 moles. And so if you divide that, you're going to get 0.006. So after you get the 0.006 in the midst, you're going to times that by 1,000. So which one looks like a 6 there? B, right? So if you're gonna put this together, get your pen out because you have to put down your work. First of all, you're going to take 1 liter times 0.10, and that is going to equal what? That's going to equal 0.10, and then 0.10 you're going to divide by 18, which is 18 moles. And so if you get your calculator and put down 0.1 divided by 18, you're going to get 0.006. But it's 18. As you divide it by 18, you're going to have to put this number now, 0.006, into milliliters because it's 0.006 liters. So to change it to milliliters, you times it by 1,000. And so you move it over. I don't know if you see, well, you can do this, so you move it over. So you end up with 6 milliliters. So I hope you're listening, but basically you times those, where it has the of, you times those two, and then you divide by the 18 and you get the number, and then you have to times it by 1,000 to get from milliliters to, or from liters to milliliters. Number 10, what is the concentration of a solution containing 0.1 mole of KMNO4 dissolved in 500 grams of water? Okay, so what are we going to do with this? What is the concentration of a solution? As we put this together, you're going to take the 1 mole, 0.1 mole, and divide it by 5.5 grams. So take your calculator, say 0.1 divided by 0.5. Well, in doing that, you're moving over the decimal point over one space, and you're going to get 0.2. And then so it's going to be 0.2, and the point, 0.2, and then the 0.2, you're going to have to times that 0.2. So, oh, actually, you don't have to. It's just going to be 0.2. So I was going to think you'd have to times it by 1,000, but it's already there. So the 0.2 is going to be D, 0.2. All you have to do is take, 5 goes into 10, how many times? 2, and make sure you put the 2 there. So it's 0.2. I hope you got that. But anyway, so let's, I was going to go on to the next quiz. Let's see. We're going to do quiz M. And I don't think you have quiz M, so you just need to put this quiz M down and give it to your mom. But quiz M says, what kind of solution contains all the solute possible under equilibrium conditions at a given temperature? So what kind of solution? A saturated solution. Contains all the solute possible. Fills up the solute. It's saturated. So quiz M number 1 is saturated. Quiz M number 2. What term refers to the total heat absorbed or released when one substance dissolves in another? Heat. The word is heat. If you look in your book, another word for heat is enthalpy. A-N-T-H-A-L-P-Y. Enthalpy of the solution is the heat of the solution. Enthalpy means heat. E-N-T-H-A-L-P-Y. So that would be your answer. Number 3, in what type of equilibrium are reverse processes constantly occurring at equal rates? So basically you're having, as for chemical reactions they keep going until they're at equilibrium, but they're still going, and they're still reversing and going back and forth. You call this kind of equilibrium as dynamic. It's dynamic because it keeps going, like dynamite keeps going or whatever. It's dynamic. Dynamic is D-Y-N-A-M-I-C, equilibrium. E-Q-A-L-I-B-R-I-U-M. So, number 4 is a true or false question. The solubilities of gases increase with decreasing temperature. So basically, as the solubilities, when the temperature goes up, are they going to decrease or increase? So when the temperature goes up, the solubility goes down. It's opposite. So that's a true statement. Number 5. What will happen to the solubility of gas at a given temperature as the partial pressure of that gas increases? So as the partial pressure increases, that means the atmospheric pressure increases. We're talking about being at sea level or being top of that mountain or whatever. But as the pressure increases, as the pressure increases, the solubility will increase too. So pressure and solubility go together. The temperature is opposite of solubility. So as the temperature goes up, solubility goes down. As the temperature goes down, solubility goes up. Now with pressure, as the pressure goes up, the solubility goes up. They go together, right? They're directly proportional. So that's it for quiz M. I have quiz 20, but I'm not going to do this right now. I'm going to basically do it at the ends of test 8, so of another video.